Before we start solving quadratic equations, it's important to realize what quadratic equations look like, what the solutions may look like, and how we might go about solving them in terms of different methods. So when I think about quadratic, I'm really looking for a largest power of 2. That's the telltale sign that I have a quadratic equation. So if I look at an example of what this would look like, it might be something like 4x squared plus 6x minus 12 equals 18x plus 2. That's going to be an equation, obviously, because of the equal sign, but it's also going to be quadratic because I have a highest power right here of 2. If I were to simplify like terms, that 4x squared term would stay. So I have a quadratic equation. Again, largest power of 2. When I'm solving quadratic equations, it's really important that I remember that every quadratic has exactly 2 solutions. So when I'm solving, I have to find both. Now these solutions can take on some different looks. I could have 2 real solutions. Now those real solutions could be either rational or irrational. So they could look something like x equals 3 and 7. That would be a set of rational solutions, a set of 2 of them. Or it could be something like x equals 3 minus 4 root 2. And if I want to make it the 2 solutions, I would have plus or minus. So 3 plus or minus 4 root 2 would be another set of 2 real solutions. Again, in that case, irrational. Now, they don't have to be real. I could have 2 imaginary solutions. I would write those as complex numbers, traditionally of the form something like x equals 3 plus or minus 4i. But there could also be a radical in there. Now, the one thing really important about imaginary solutions is they always, always, always come as conjugates. Every time I have a set of imaginary solutions, it's going to be a conjugate pair. Last but not least, I could have 1 real solution. And that seems to fly in the face a little bit of this right here where it says exactly 2 solutions. So how do I get by saying that I have just 1 real solution? Well, if my solution is something like 4, then I go through and I call that a double root. In other words, I'm going to count them twice. I have 2 solutions. My solutions just happen to be 4 and 4. So I list it once, but I have it twice. When I think about the different methods to solving a quadratic, we're going to talk about 3 different methods. And these methods have different times that they're appropriate to use depending on the situation. The first method is going to be the square root property. And one little catchphrase about square root property to remember is that I'm really looking at inverse operations. Anytime that I can just use inverse operations to solve, I can use square root property. The second method is factoring. A lot of people just label this as a method of factoring in terms of solution, but I really like to pair him with what's called the zero product property, because without the zero product property, you can't use factoring to solve. And last but not least, we have the quadratic formula, probably the most famous formula in mathematics. And the quadratic formula is useful because it can be used anytime in order to solve any quadratic ever. So just a little preview, quadratic formula looks like x equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. Again, I can use quadratic formula for any quadratic I ever need to solve, and it's a little bit more tricky in order to use method 1 or 2 in order to solve a quadratic because there are very specific cases when those would work. So those are my 3 methods that I'm going to expand upon as we go through some other examples.